Hello and welcome back. Okay, today I'm going to work on a circuit that I've been meaning to do for quite some time. So this is my bus tester board. Now what I've got here is a loose collection of circuits that I use to generate signals that are appropriate for my pipeline CPU and also respond to signals in return. So I've got some LEDs to display what's on the bus. I've got a set of dip switches that can generate a set of values that I can push onto the bus. And I've got some debounced buttons that can generate active low signals that will drive appropriate control lines. And I've kind of been adding and subtracting bits from this. But as a breadboard circuit that's been built on cheap breadboards and with imperfect wires, as it's aged and I've done more and more tweaking on it to suit appropriate purposes, it's gradually become less and less reliable. And so what I'd like to do is take the common use cases of this and transfer it to a PCB. So let's take a look at doing that. Okay, so we've got two sides of this. We've got the digital signals and we've got the 8-bit bus section. Okay, so the 7414 is just like the inverters we've used before, but it's got the Schmitt trigger inputs. Okay, so in theory the circuit for this is very simple. Now on the breadboard I've got 3 digital lines, but it'd be nice to have 4. Okay, so each of these capacitors is either pulled up gently, or when we depress the switch, we pull it quite sharply down to ground through a lower resistor. So then we feed the output of these into the 14, and these are inverters, but they have the Schmitt trigger inputs, which are going to give us the nice clean outputs we want. Now I'm going to re-invert them to get a clean version of the original signal. Now on the breadboard version we only had the inverted forms because that's where we're going to get most use, but I would rather have that. Not going to use those ones, so we need to pull the inputs down. I think I've got use for these. Now this is actually the main functioning circuit. What do people think is the neat way of putting the decoupling caps in? I don't like crossing these lines. That might be better. Okay, I've got these the wrong way round because these are pulled up, so the switches produce high input when released, so the inverters are going to produce a low when the switch is up and a high when the switch is down. So I need to switch all of these around. Let's get some LEDs in here as well. I think probably slightly more separation on the switches. It's going to be easier to route if I invert them. You're going to cross connect the two sides. It doesn't feel very tidy, but it's better if those nets are connected. See, those lines are a lot cleaner now. These LEDs don't have the direction arrows on. I don't like that. These ones do though. Now electrically, this change doesn't really make any difference. It doesn't matter which way it goes between the digital signal, the LED and the resistor. It's still going to limit current in the same way. It's going to be a lot easier over here, and these nets are going to be named in a way that's useful to us. This would be better the other way around. Okay, I think that's the 4 digital switches we wanted. That's kind of cool. Now the bus side, we've got an 8-bit bus with some LEDs attached to it, and we've got a set of switches that can be conditionally pushed onto the bus. Right, so that gives us an LED display for the lines on the bus. Now we need to create the switches. Okay, to make the wiring easier, I'm actually going to put the switches in upside down. So that allows me to use the switch on to pull the line down to ground. Okay, so the main bus display might be taking data internally or from outside. The switches are producing a value that needs to be conditionally put on the bus. On the breadboard version we used a 541 line driver. Oh, I do have some spare 540 line drivers. That would be good actually. So we don't need to put this upside down. I was thinking about having a second 04, which would give me 8 inverters, but using the 540 rather than the 541 here, which is the version with inverted outputs, lets me avoid that. Not making myself an easy life here. That's going to be nice. I want these LEDs to be green because they're signals. So that needs to be 2K. These are going to be blue, so it's 4.6K. These pull-ups, I'm just going to make the highest value I've got at the time, which might be the 4.6K as well. Got loads of those though. I'm going to put a random pull-up there because this signal is not necessarily going to be used all the time, and we don't want a floating input on this. We would like a decoupling cap though. Okay, so now we've reproduced all the functionality on the original breadboard. I would like to add one additional piece of functionality, and that's a register. And it basically will be the simple form of the registers that I've used on the CPU. We want a signal for load and a signal for assert back to the bus. And then we can use that to pull values in off the bus or store an extra set of values that we take from the switches. And that'll be pretty handy because if we have separate outputs for that, let us do 16 bits, make it an all-round better bus tester. Okay, so that's the output side. I'll take the value, push it onto the main bus. So a set of LEDs to output the status of the register. Got pin headers to output the register already. Now we just need the register itself. just the same, I think we want pull-ups on those lines. And I think that's done. Could do a bit of tidying up on the schematic. Seem to spend half my life swapping the order of lines. Got them all wrong again. Does make sense since I copy paste them from the bus input. These will be red, so I want them to be 1K. It's 127mm wide. If I could save that little bit off the width, that would drop the price, even if I had to make it taller. Much better. Okay, I guess it's time to see if we can route this. I like the symmetry of these resistor arrays down here, but this one is clearly going to be better higher up. Although it would be one unused, I think a 4 resistor array might be better here just for neatness. Right, I'm going to make this a 4-layer board because I know we're under the 100mm by 100mm size where things get quite a bit cheaper. Now I suspect the toughest bits are going to be the groups of 8 lines around here. So let's route those first. The main bus side of it was deceptively easy. Okay, so these lines from the switch, they're going to be a little bit more difficult. I think the routing would have been easier if I had reversed the lines on these 3 chips, but it's not that difficult, so it wasn't worth it in this case. That could have been neater, but manual dip switches are hardly going to be a high frequency operation. Okay, so that's the bus test itself side done. Now we've got the digital signal side, but I'm expecting that to be pretty easy. Okay, I feel that was far easier than I had any right to expect, mostly because this board is quite well spaced out, particularly over here. I think we should add ground planes to the top and bottom layer, as we usually do. I think I'd learn to take note of what the net value is currently set to. See, I should probably distinguish between the male and female versions of these, just so the 3D view looks okay. It doesn't really affect us when we're soldering. But I think that's going to be a nice little board, and I'm hoping it's going to be a lot more reliable and a little bit more helpful than the breadboard version. Let's get those made. Don't think I've ever had a black PCB made so far. Let's give that a go. Always careful here, because if you leave the default size you end up with a massive stencil, which is actually a little bit unwieldy, so it's easier to shrink it down. Hope I got the right parcel here. I do like this black. Alright, let's solder one up, see if it works. Okay, that actually looks like we've got some misalignment. Sure, I had that aligned well. And for most of these things, it doesn't really make much difference. Okay, this may be tricky. Let's give it a try. So I'm missing a little bit of solder on this one. Don't know whether it's best to hand solder it or try and squeeze a little bit extra on. That doesn't look too bad. That must be the 14. Yes, it was. Of course, these two devices have almost identical symbols. Now that does feel like it's not a perfect match for the pads. Right, so it's a 541, which is that. Made that mistake again where I put the text upside down relative to the footprint. Okay, so I actually picked these up in the right order. It should be a 540. Very difficult to read. There we go. Right, now we're onto these rather scary pads. Now we get to see how forgiving these things are. But we have had issues before and been able to solve them. Now you notice I haven't put solder paste on these switches. That's deliberate. I find they're a lot easier to hand solder. The way those resistor arrays are snapping into place does look promising. Right, let's take a close look. Not expecting much problems from these larger components. It's not totally clear how good the connections there are. Small solder bridge. Joint there looks like it could be dodgy. So the solder flowed pretty well, but it looks like the upshot of the slightly smeared application is we've got a bunch of smaller bridges. Right, I think I've got those. Don't need that same level of zoom for these. Alignment on that one looks pretty bad. Marginally better. Uh-oh. Missed one. Did I miscount these? Yep, there's 6 of them and I only had 5 on there. That one looked perfect. I would say these black PCBs make it a little bit harder to see how well the solder's going on. I'm suddenly asking myself if I cleaned the underside of the PCB. That can sometimes make quite a big difference to the solder flow. Time for the secret weapon of pin alignment. Separation between these wasn't a full space. Probably very obvious to you, but it's obviously a chunk of time for me while the PCB got made. It does feel like this solder mask isn't as effective. Okay, see if we can get this to work. Okay, that looks really promising. Now we do want to get the scope in here so we can be sure that we're actually getting the kind of signal we wanted. At first glance, that looks good. Yeah, it's excellent. And of course, the second hole there is inverted. So then we've got signals here that control the behaviour over here. I'm seeing that line as on when it shouldn't be. So that line, so that's high, and that's low. Willing to bet there's a misconnection here. Okay, it's that line there. Very awkward to get at. But I think it's not made connection, not as easier to see. Well, we've just made it lots worse, and I can see why now. It's just that same problem one. I think I'm misinterpreting the problem here. I think something's pulling it down to ground. Test the other options. If we tell that the switch is to assert to the bus and then tell the register to load, that seems to be fine. apart from when we load, we've got the unexpected line set here because that's what the switches are outputting. So everything seems to be working perfectly apart from that one line there. That's very frustrating. Now, this could be this switch failing to switch. That seems kind of unlikely though. So something is connecting that line to ground. Okay, that's weird. That looks like the solder paste didn't melt properly there. I do see some of that solder paste around the base of that pin. That's got it. Yeah, that line works now. What I really need is an ultrasonic cleaner, I think. I didn't spot that the paste hadn't gone properly there and it spread out a little bit and caught the other pin, shorting it. That's cool. Okay, I'm pretty pleased with this. Okay, I'm really pleased I got this going. Now, I think I would benefit from getting an ultrasonic cleaner, which is actually something I've been meaning to do for a while, because that would allow me to clean up the PCBs and kind of flush out, particularly underneath some of these chips where it would have become a lot more obvious that I had that problem. But hopefully this is stable and fully working now. Now, I have had some circuits where this would have helped. And particularly I'm thinking about the audio channel circuit. Testing that was a little bit of a pain using the old bus driver circuit. But this one should make it a lot easier. And I'm hoping to start building the circuit that's going to drive those channels in the near future. So I'm going to look forward to that. Hope you found this interesting. Thanks a lot and goodbye.